All right, so we're going to continue our factoring odyssey, chapter 5 test, form A. All right, let's factor. So we're going to factor this completely, and I know that I'm going to rewrite the problem because, again, it's hard to see. So we have 5a to the, look at my paper, third b squared minus 10a squared b squared, and then plus 15a squared b. All right, so the first thing I'm always going to look for is a greatest common monomial. That is always number 1. So I can't help but notice that 5 goes into all of them. They all share a factor of a, and the smallest a, the smallest a we have is a squared, because a squared goes into a to the third. The smallest factor of b we have is just a plain old b. All right, so we're going to divide each of these by 5a squared b. All right, so 5 divided by 5 is 1. A to the third divided by a squared is a. B squared divided by b is b. So that's minus 2. A squared divided by a squared is 1. All right, b squared divided by b is just b. All right, and then finally we got 15 divided by 5, which is 3. A squared divided by a squared is 1. B divided by b is 1. So there we go. That's it. I can't factor this any further, so I'm done. And I know I can't factor it any further because there are no squared terms here and there's no other common monomial. All right, that wasn't too bad. All right, number 9. Ooh, my favorite type. We have 9c squared minus 25d to the 4th. And I can't help but notice that 9c squared is a perfect square. 25d to the 4th is a perfect square, and I have no greatest common monomial I can factor out. So I have a difference of squares. All right, difference of squares will have 2 pairs of parentheses. What times itself is 9c squared? Well, that's 3c, 3c. To get a negative, I have to multiply a positive times a negative. So I have 5, because 5 times 5 is 25. D to the second, d to the second. And there we go. Number 10. So in this one, we have e squared minus 4e plus 4. So the first thing I'm looking for is the greatest common monomial. I don't have one. Second, a difference of squares. And I know I don't have one because I have this linear term here. It's just not going to work. But 4 is a square and e squared is a square. All right. So I'm guessing, I'm pretty sure it's going to work out, that this is a square binomial. But if you don't remember that, remember this. I can look for factors of this last term, 4, that have a sum of negative 4. Well, okay, so what 2 things are equal of positive, multiply together equal positive 4, but add together I get negative 4? Well, I could try negative 4 and negative 1, but that's going to have a sum of negative 5. No good. All right, so we have negative 2 times negative 2, and that gives me a sum of negative 4. All right, so this is going to be equal to e minus 4 squared, because it's the same, sorry, e minus 4, my goodness. That is for the really big mistake. There we go. Because I have taken both of them, right? So it's going to be the same thing. So this is my complete answer here. All right. Number 11. So we have f squared plus 3f minus 28. Now, I don't have a greatest common monomial. There's no difference of squares because this 28 is not a perfect square, which also means it is not a square binomial. So I'm looking for a binomial pair of factors. Same idea. I'm looking for factors of negative 28 that have a sum of 3. All right, so right away, I know I'm going to have f and an f, and I have to have one positive and one negative. Okay, so what times what is 28? Negative 28 that add together to make 3. Well, obviously we have 7 and negative 4. and that has a sum of 3. Because there aren't too many other ways to make up 20. I mean, you can do 2 times 14, but we know that's not going to be 3 apart. So the 7 is positive, the 4 is negative, and there's my answer. All right, I think I have time for 2 more. Stay within 10 minutes for each video. All right. So then for number 12, so we have g, that's an a. We have g squared minus g h minus 30h squared. And again, I'm looking for factors of negative 30 that have a sum of, that's a 1, negative 1. All right, and I also know that I'm going to have a g, I'm going to have a plus, I'm going to have a number and an h times g minus a number and another h. All right, so what times what is 30? That's 1 apart. Well, geez. Well, that would be negative 6 and 5, right? Because when I multiply those together, I get negative 30. But when I add together, I get negative 1. Winner, winner, chicken dinner. So my positive is 5, my negative is 6. And there we go. All right, next problem. 13. 6j squared plus jk. Just joking about giving you a test now, but I really am. We are going to have it. Sorry. Squared. All right. So this one starts to be a little more challenging because I have an a term here and I have that negative 35. So here's what I do. I'm going to first say that, okay, I know I have a number, j. This is a negative, so then I have a 1 positive, a number, and a k. And using the same logic, I'm going to go with a number, j, minus a number, and k. I need to, it's just like Mad Libs, I need to fill in the numbers. So I know 6 has factors of 1 and 6, as well as 2 and 3. I know 35 has factors of, well, the most likely one is 5 and 7, and that's pretty much it. I mean, I could use 1 and 35, but the 35 is going to not be good. So here's what I'm going to try to do. I'm going to try to multiply one of these numbers here with one of these numbers here. And then I want to multiply the remaining number of my pair with the remaining number. And hopefully I'm going to get 2 numbers that have product. Once I get their products, they're going to be 1 apart. So I can't help but notice that 3 times 5 is 15, and 2 times 7 is 14. That's 1 apart, just like that middle piece. So that means I have to multiply the 3 times the 5. To do that, I need to keep them opposite. So when I do my rainbows and smiley faces, I'll get 3j times negative 5k. Oh, wait, I don't want it to be negative 15. I need it to be positive 15. Oh, geez. So, in that case, the 5 has to be positive to get positive 15jk, okay? Which means the remaining 2 and the remaining 7 have to go here. When I multiply these together, I get negative 14jk. All right, so there's my answer. Woohoo! I love factoring. All right, so the next one, we have m minus 2n plus 3p times 2n minus n. All right, this will be the last one for the video. All right, so I can't help but notice that this and this are really painfully close, but they're not quite right. And the only way I can factor this whole thing or make it look simpler is if I have the same binomials. So I'm going to factor out a negative 1, and that's going to switch the signs. All right, so if I factor out a negative 1, that negative 1 is going to have to be applied to this one as well, right? Because whatever I factor out doesn't go away. It just gets multiplied to the front. So negative 2n divided by negative 1 is negative 2n. Negative m divided by 1 is m. All right, this is starting to look good. Negative 1 times 3p is negative 3p. Okay, so I have m minus 2n, and that's just a 1. All right, so this and this are the same. So I do have m minus 2n, this. And both the 1 and the negative 3p are going to have to get multiplied to this, right? So then that means if I put them together, when I do my rainbows and smiley faces, I will get the same multiplication piece as I will here. All right. So there's my answer.